Vegan Bharti with your mentor Abhilash Sarkar. Up next is coming on Matrix is a new concept. I would not say the concept. Basically, it's some facts on matrix. That is, matrix also, as in algebra, we can do some of operation just like uh, summation, subtraction, multiplication, and all that. So in matrix also we can do some of this, if not all. So what are the functions or the operations we can do? The first one is addition, definitely; subtraction, definitely; multiplication. We cannot do division in in matrix. So we'll only can do these three operations. One is addition, one is subtraction, and another is multiplication. So we'll see it one by one how we can do it. Okay. So for that, if I can go with the heading operations of matrix. I will name it like that. Okay. So what are the operation? First one is addition. Second one is subtraction. And third one is multiplication. Okay. So each having its own way of doing it, and each having its own process. So we cannot do division in matrix. So this is the limitation of matrix. Okay. So nevertheless, we'll go one by one. So for that, we'll take at least two matrices in operation where we can see how that addition go ahead. So let me take A is a vector. Okay, A is a matrix. A and B, let's say, are two matrices of order, any order, but condition is that the order of these two must be same. This could be of any order individually, any order I will not say individually, then that goes on other direction. What is the limitation? This A and B can be of any order. Let's say if I say A is order of M and N and B is order of P and Q, let's say P and Q, but my condition is that order M must be equal to P and N must be equal to Q. So that means this must be of same order. At the end, without saying so much of complicated way, if I say that must be of any order, but the order of these two must be same. So this is the condition for summation or addition. You can call it a summation also, as we call in other algebra. Summation. Okay, summation or addition, where the condition is that the matrix has to be of same order. Okay. So let's say A is a matrix of order M and N, and the B is another matrix which is the order of M and N. So when you do add this, okay, so let's say I am getting one other matrix. So this, if I can represent it C by J, of that must be of same order, because on an add of same order two matrix, the resultant also will get so of same order. If it is Mn, this must be Mn, and the addition will be of Mn. So the first thing that we will observe, the order of the matrix should be same, and what is relation, because I am taking any generalized terms which is representing by this row and column, this row and column, and we are keeping all the row and column same. Ig I am taking here, Ig I am taking here, Ij. So if I see the position of this, and position of this, as the order is same, are same, all these having of the similar. So what would be the relation among them? I would get Ij plus Bij is equal to Cij. So this will be the relation. Okay. So that means the same elements, same located elements have to be added together to get the same located element in the resultant matrix. Okay. So let me take some examples so that it can be more clear with a with a real example. Let's say A is denoted by, I am taking A, A1, A2, A3, and A4, A5, A6, A7, and this time I need not to take it as a square matrix because I said this could be of any order. So let me take it in the order of 2 by 3. So then if I add some matrix, that must be of same order, I said. So this also must be of same order, B2, B3, B4, B5, B6. So what I said, this basically, if I really denote this by the row and column, this is 1 1, this is 1 2, this is 1 3, 1 4, 2 4. Let's say I'm writing it in the order of their row and column. This is 2 1, 2 2, 2 3. So in a similar fashion, I will write it here so that it will give some sense, because I can take in any elements of any value, but when this is being represented in a generalized form, so I should follow with the row and column, because there in the definition I said Ij, so it better be represented with the same thing. Okay, so 2 1, 2 2, and 2 3. Okay, so now this you can see the order of the matrix are same in both cases. This is of 2 by 3, that means 2 row 3 columns, 2 row 3 columns. Now we can add this as per the condition of addition or summation. The first condition is fulfilled, order is same. So now I can go with the adding. So this I will get something. If I say of the same order, I am getting some matrix C. So the elements of that has to be in the same form. Okay, so now what is the condition? I said Aij plus Bij is equal to Cij. Now by that relation, by that condition, if it is so I have to add this with this. So A11 plus B11 has to be C11. Okay, so now I can replace all these values. So what would be the ultimate picture of the resultant matrix? That has to be A12 plus B12, and this is A13 plus B13. This has to be A21 plus B21. This has to be A22 plus B22, and this has to be A23 plus B23. Okay, so that means we are adding the same located elements and getting the result. So this is the straightforward resultant of the matrix when we add it. So first you have to see the order has to be same. That means number of row and by the number of column order always has to follow with row and column. That you have to keep in mind. So row and column it is same. So this may not be somewhere it is being written, so that you can find this order is same. Sometimes you have to judge yourself by seeing the rows and columns. You don't mistake it. It may not be there always in the question paper also. So you have to judge yourself whether A and B of same order or not. That you have to judge yourself. Okay. So this is the summation. And if I go to the subtraction is just a different just a difference between this addition and subtraction. This will involve negative sign instead of positive sign. So that means if I say A minus B, the rule is same. The order of A and B must be same. That is the first rule. And the elements that I will get now, whether the elements of A and B, whatever the relation, if I want to get A minus B, I have to keep the elements in the same order. Whether B's element is higher than the A's elements, it doesn't matter. You cannot manipulate by switching the location. You have to keep the arrangement in the same way, because I cannot say A minus B is equal to B minus A. For subtraction, it is not commutative. The result will be different. The result will be the inverse. Result will be the negative of the matrix. We learned already negative of the matrix at what? It will be the B minus A is the negative of the matrix. You cannot say A minus B is equal to B minus A. So whenever you are doing subtraction, and as per the need, if it is said you have to find A minus B, so accordingly the elements has to be arranged in the same order that is needed here. Just keep it in mind. Otherwise, everything is in same way being done for subtraction. Okay. So remaining term you can understand. So this is your subtraction. So let me take one example, or numerical example. A is equal to, let's say, 2, 3, 1, 1, 2, 3, 3, 2, 1, let's say, and B is equal to 4, 5, 6, 6, 5, 4, and your 5, 6, 4, let's say. This way. Now you have to do A plus B. So what you have to do? You have to add the elements. 2 plus 4, 6, 3 plus 5, 8, 1 plus 6, 7, 1 plus I have taken 3 by 3, okay, anyhow, so order is same. So 6 plus 1, 7, 2 plus 5, 2 plus 5, 7, 2 plus 4, 6, 3 plus 5, 8, 1 plus 6, 7. Then next is 1 plus 6, 7, 2 plus 5, 7, 3 plus 4, 7 again, 3 plus 5, 8, 2 plus 6, 8, 1 plus 4, 5. So this will be the answer. Okay. Now if I go for calculating A minus B for the same matrix, the result will be 2 minus 4, that is equal to minus 2, 3 minus 5 is equal to minus 2, 1 minus 6 is equal to minus 5, 1 minus 6 is equal to minus 5, 2 minus 5 is equal to minus 3, 3 minus 4 is equal to minus 1, 3 minus 5 is equal to minus 2, 2 minus 6 is equal to minus 4, 1 minus 1 minus 3. Now see, if this is the case, although I got a result, all are multiplication of -1, so that I can take, because that is a scalar for this matrix, and I can convert this matrix. This -1 doesn't mean anything, so only minus will come, so and the remaining thing will get positive, and the matrix will turn into a matrix negative of a matrix. So this is the matrix, if I say, so this is negative of matrix. That also can be possible, because this is a multiplication factor, is a scalar being multiplied for with all the terms, so that is -1. I can take it out and I can convert it like that. Okay, so this is possible, but the result will come in a same order that is being needed. Okay, next come your multiplication. Multiplication is bit a different concept, so this need to be practiced more. The third operation is multiplication. Okay, so the multiplication for a multiplication of matrix, the condition is a very unique condition. Condition is that the number of column of first matrix, first in the sense the way it is being arranged. If I say A cross B, then you have to consider A is the first matrix, and you have to consider the column in first matrix means A matrix only. Okay, so the number of columns in the A first matrix must be equal to the number of rows in second matrix, and we can do multiplication of two matrices at a time. We cannot go more than two matrices at a time. So we have to remember, when we are doing multiplication of matrix, we have to do two matrices at a time. Okay, so this is also a restriction. We can do multiplication of two matrices at a time. Okay, so this also be one of the constraint. We cannot go with a multiple matrix multiplication at a time. So we have to take care of this. So there we can compare that the number of columns in the first matrix has to be same as the number of columns in the second matrix. Now let's say a matrix of size Aij is m into n, and another matrix B, the size of is equal to n into p. So now see the number of columns in the first matrix. If I want to get A cross B result, so you have to see the number of columns in the first matrix, because this is position first, and the number of rows of the second matrix, this is position second, must be same. This is the first condition, you have to be same. Okay, equal. Now we cannot calculate B into A, as because when we place B into A, the first will be the B. So in that case, the number of column is this. For A, number of rows will be this. So n not equal to P. So then we cannot compute B cross A product. Understand that? Okay. So this is the condition, and third condition is that order could be anything. Order of the matrix may differ. The order of matrix may differ. Okay, as for A, what we have taken m into n, and for B what we have taken n into p. So the order here and here, overall orders are not same. Only part of this which is the column for first and the rows are of the second has to be same. Okay, so these are the precondition for multiplication. Now how to do the multiplication? Okay, so if I say how to do the multiplication, so let A be ij of m into n order and B, as I said, n into p order. Okay, so now if this is being represented in elaborated form, so A11, A12 like that, it has to go to an, and this is A21 like that, it will go a m into 1. Number of rows m maximum, number of column n, and so as if I represent B will be 1 1 1 2 dot 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 B 1 P, n into P, number of columns is, this will go up to 1P, and there B will go up to n into 1. Here number of rows is n and it will go, and this way the overall. Now when we do multiplication A cross B, I will get some matrix, let's C, and C is represented by Cij, and the order of this will become the extreme value of the cumulative of two orders. Means this is order of m into n, this is order of n into p. So the order of this will be the value taking the extreme values of the cumulative of the both the matrix. So that means the extreme is m and n is the extreme. So the order has to be m into p order. The resultant, what is the C is the resultant of the product of A and B, that will C, and the Cij is the term which will represent the ith row and jth column, as it is ith row jth column. And what would be the relation with this? How will I get the relation? So that I will tell you. But before that, what would I have to fix the order? So order has to be the extreme one, because this value has to be same when you do multiplication, and the remaining order will fix the order of the resultant. So that has to be this one. Now comes what is the relation between Aij and Cij. So Aij and Cij will be related as, so what would be the value of Cij? It will be the value, if I write it in a form that this is k is equal to 1 to n, okay, and a I, and this value will be I goes from 1 to k into b k to j. This will be the value of the position. Okay, I will explain it how it is differing or how it is related. So I mean to say, if it is I and j, the value will be calculated or can be derived if I put a variable k here, and k value will vary from 1 to n, where n is the number of column of A and number of rows of B. That we know, because n is the common number which will be number of column for A and number of rows for B. That has to be same, and this n is representing the same n where k value varies from 1 to n. So that means if I expand it, the things that I will get for any, let's say I'm just getting C11 if I want to get. Okay, so that means here I is 1, j is 1, that is fixed for a particular element of the resultant matrix. If I say, and k will vary within that that element, means if I say a particular element I'm talking about of the resultant, what are the values it will contain of a and j, because C11 it is an element of the resultant that represent the ith row and jth column, and that is formed by all these values of a and b. So if I put a specific value C11, what would be the value where C is represented by Cij whole into m into p. So that means Cij means there would be C11, C12 like that, C number of column. This way this will be go up to CM1 like that, and it will end at CMP, isn't it? All the terms like that. So out of that, if I want to calculate C11 by this formula, where I am saying the Cij would be the summation of k value, where k have taken a variable k value 1 to n, and there aik and vik, the value that will define a specific value of in, specific value of their column here and the rows. Because what I am doing the multiplication of, if I say this is I like that, I this is up to n it is going, this is I m, this was m and n, m1 dot 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 c a m n, that is the a's value, matrix A, and b was, if I expand it, b11 to, and that was order of n into p. So that means number of column is b1p, and this side it is bn1 to bnp. So what I am doing, I am multiplying this with this column, rows of A and one column of B. So I am taking specific row multiplication and specific column. Let's say I am multiplying row number 1 to column number 1 of B, row number 1 of A, column number 1 of B, and there this much of several of terms that is being individually multiplied. So this is the case. A, if I put a specific C1, okay, and J1, so I am talking about C1 of this, that means 1k, so this will go up to k, and k varies from 1 to n, so that means the whole total row. These terms, if I take this as a particular, this will represent all these terms, isn't it? A1, K1, this one, K2, 1, 2, this is 2, K, like that up to n. This is the total row. And for B, summation B, if I take, K varies from, and for J is equal to have taken, the second term is J, the K is varying from 1 to n. So the first row and first column, if I take, that will give you the first element of the resultant. Understand? So this is being represented by this formula. Now what will be the case of C11? So what is the value? A11, B11, isn't it? If I put I is equal to 1, J is equal to 1 for first case, so this will contain how much? I1, K1, A11, K1 already taken, J1, then B11. The first term of this plus, this will all be added with a plus sign because this is summation sign. So then next I am taking I1 already taken, K value, next value is 2, so 1, 2, 2, 1, A 1 2, B K have taken 2, so B 2 1. So that means 1 2. The next is 2 1. So this to this I am multiplying. Similarly, plus plus plus, and I is 1 already, K is N. So that is A is 1 N and B is N1. B N1. So the last term is 1 N and the last term of this is N1. So this will consist only a single term of the resultant C11. So similarly all these terms will be calculated with this formula. So a single term of the resultant will be produced by this formula. So each of the term of the resultant will be produced by this. Okay. So this, if you are thinking maybe very high calculative method, but sometimes we will not work with so big of matrix. Maybe 3 or 4 order of matrix will work with. So then it will not be very much difficult to find the multiplication of the matrix. Okay, if it is a bigger one, so definitely what you have to do in software, you have to put this formula and I have to run a program on it to get the value of this. Nobody will go on calculating a bigger matrix by hand. That they will put it in program. Okay, that is a different story. But when you do some example in your academic or exam, that would not be a very much big problem. Otherwise, it would be it's a big trouble for calculation, because this you cannot skip. Every time you have to calculate all this. So let assume we will work with a very small order of matrix. Okay. So this is the process of multiplication. Understood? So let us take some example so that and I will take some lower order of matrix so that it can be cleared easily. Okay. So let's say one of my matrix is, I will use different chalk for this. Let it be 1 2 3 3 2 1. Okay. As I said, I will not take a uniform one. So B I will take with a different chalk. Let me take let's say B is this. You can understand what is the order of that. Let me write it 2 cross 3. Now B I have to take order 3 has to be common, because number of column here has to be the number of rows there. So that I will maintain. Okay. So this, let me take just the similar kind 1 3. I am keeping the number same so that it will be easy. I am just keeping the digit same. I will just reverse it. Now this is order of 3 cross 2. Now if I multiply, if I do product of these two, first thing that I will get is some matrix. The order of this must be 2 cross 2. That has to be there. Okay. Now while we will calculate, what we will calculate? I will go on multiplying row by column. This row by this column. That is very simple and straightforward. Whereas if you see the derivation theory, it could be very much confusing and very much tougher for you. But it is not like that. If you see the real problem is somewhat very easy. So what I have to do? I have to multiply this into this. 1 plus 2 into 2, 4, 3 into 3, 9. This is my first term completed. Okay. Now this row, second column, if I multiply, so this will get, because first position 1 1, where I value, you just remember, is 1, j value is equal to 1. For the second case, second term, I value is equal to, rho is 1 and j value must be 2. So where will we land? J of what? J of this. I of first, j of this. In the formula, if you remember that Cij, how will I get? K is equal to 1 to n a I k into b k j. So j is for what? B. It attached to B. So B, the matrix which is a element of B, is carrying the j, and I is related to the elements of A, the first one. Just remember this part. It will be very easy for you to calculate. Now what I do to get the resultant, because j of C is representing j of B also. So what is j here? J I am taking 2 of B. Okay. So I of 1 means this row, this column. The next position will be I1, J2. J means second column of the resultant and J is the second column. So this way you can remember, J when it is 2, you have to see the second matrix. So this is 1 into 3, 3 plus 2 into 2, 4 plus 3 into 1, 3. That completed. Now second, I2, J1. I2 means when I see I2 here. Okay, I of first, J of second, means the first one. So the third will be I2 J1. So that means this into this. So what is that? 3 into 1, 3. Okay, so now this is I means second row of C. So I is 2. That will follow the 2 of this. So I is commanded by the first matrix, J is commanded by the second matrix, like that. Okay. So this 3 into 1, 3, 2 into 2, 4, 1 into 3 plus 3. The last one remaining, it is 3 into 3, 9, plus 2 into 2, 4, and 1 into 1 is equal to plus 1. So this will be the ultimate result of your matrix. Now see, there is no other number will come. So the order is 2 is to 2. So that follows 2 and 2. The same as I said in theory, that is matching. So your result will be 9 plus 5 is equal to 14, 17, 10, 3, 7 plus 3, 10. This is 14 again. Now this can also be somewhat extended, because all are multiplication. There is a common factor of 2. You can take 2 out, and you can, because 2 will be scalar then, and this will convert, reduce every term by half. Okay. Now this will be your answer then. Okay. Now further, if we want to get the value of it, this is a 2 by 2 matrix. 7 7 is a 49. What I have done, this to this minus this to this minus 25. So this is equal to 2 into 49 minus 25 is equal to 24. So ultimately your answer will be 48. Okay. So this way you can solve the multiplication well. Okay. I will end up here. I will move to the next part of matrix in the next video. So till then you can see the things that I have described. Try to memorize or try to understand its better way. More you revise, more you understand. Try to do some sums of your own on this basis, and that will be your practice time. Okay. So thank you for now. I will come back with more number of theories and insights on matrix again. Thank you.